Hi, everyone. Welcome to Azure User Group Sweden. Hi, Håkan. Happy
Hi,
weekend to
Jonah.
you.
Hi, how are you?
I'm great. It's sunny and windy here where I am. How about you in Oslo?
Yeah, there's quite a lot of sun, but quite chilly too.
Yes, yeah, very blåsigt, we call it in Sweden. Yeah, so hi everyone. I hope that you're doing great and awesome today. It's Saturday weekend, and thank you for watching us live. And today we will be having a great session about Microsoft Orleans. So, but before we do that, let me introduce my co-community leader, Håkan Silvernagel. He is a Microsoft AI MVP. He works at Miles as a manager for big data and AI. He's also a public speaker and also a community leader of different user groups such as Norwegian.net user group in Norway. And also, he is active in the AI community in AI 42, an AI school for everybody, and the AI community around the world. So it's a pleasure to have Håkan with me as my co-leader in this user group as well.
Yeah, thank you, Jonah. And I'm also very happy to introduce Jonah Anderson, who is the founder here of our user group. She's a Microsoft Azure MVP and also Microsoft certified trainer. And she is also a book author soon to be published. And she is also a mentor and international public speaker. And she has a quite new job at Solidify as a senior Azure consultant.
Yes, thank you, Håkan, for that. Yes. And yeah, so it's I hope that our this is good for, I mean, maybe our returning like audience already know us, but hi to those that are tuning into us first time. I saw on meetup that we have newcomers joining us today, so thank you. So before we bring in our speaker and our session today, let me just show everyone our community code of conduct. So as a community, we follow a code of conduct. So we expect everyone, including ourselves, the leaders, to be nice and friendly, listen with purpose, and be thoughtful. Be respectful to others, seek to understand, not criticize, and be curious to open your ideas or share it with others. Be inclusive and respectful in your comments, either in live chat or our after session meetings on Zoom. And if you have feedback or questions about our code of conduct, feel free to reach out to me and Håkan on LinkedIn. And to those of you that are joining us today, you may claim your learner badger by scanning this QR code for Azure Heroes. And we also have a recommended learning path. It's the Microsoft documentation for Microsoft Orleans for this session. And yes, feel free to grab this and mention us or Azure Heroes. It's a learner badge to those that are learning with us today. Okay, and the fika we take it later, I think.
Yes.
Yes, right.
Yes,
Go ahead.
so then let us introduce here the guest here for today, who is Johnny Hoibergs.
Hello,
Hello.
hello.
Hello, good morning. How are you?
Good morning. I'm perfectly fine. Thank you. How are you guys?
Yes, we're great. Thank you for being here and offering your time for our community. We really appreciate it. I know you're busy public speaker around conferences, see you around. So we're happy that you volunteered to share today.
So let me just have a more formal introduction here to Johnny. So Johnny Hoibergs is a consultant for Involved since 2014, and he's focusing on .NET architecture and backend development. And he's also Microsoft MVP in developer technologies since 2020. And previous to that, he had experience developing software for Corelus since 2008. And he has been very passionate about .NET ever since it was released, and his areas of expertise are C#, .NET Core, VCF, WinForms, VPF, ASP.NET Core, Entity Framework, Azure, and ALM using the Microsoft stack. So that's quite a lot. And every now and then he enjoys doing some web development using JavaScript. And since 2010, he also spends some of his free time teaching .NET and C# for the adult education. And when he's not working or teaching, he likes some casual gaming, scuba diving, learning to play the piano, traveling the world, and also visiting as many theme parks as possible. So how many theme parks did you visit?
Okay.
I have to look it up. I have a list of all the theme parks and attractions that I visited, but I don't know the number by heart. Whenever I go abroad on a trip or on vacation or even to a conference, I always try to find if there is like a theme park very close to it.
Ah, nice.
Okay. Yes. Yeah. I hope you've been to Sweden's theme park in Norway,
Yes,
Denmark.
I've been to Grønna Lund.
Mhm,
Oh, yes.
I've been to Kolmarden, the zoo,
mhm.
and I've been to the one in Göteborg. What's it called again?
Liseberg.
Yeah,
Liseberg.
Liseberg,
Yeah,
exactly.
Liseberg. Yeah. Yes.
And
Yes.
then there's
That's great.
also one near you, probably Håkan, near Oslo.
Mm.
I've been
Yes.
there too.
Mm,
Oh,
nice.
amazing. Yes. Yeah, that's a good way to put the child back in us, right? Even though-
Exactly.
Yeah, I remember I was in Denmark, in Copenhagen. My friend Marilag, who's also an Azure MVP, she showed me around their theme park there, and I really enjoyed it. I feel like I'm back as a little girl again. It made me forget, oh, I'm adult. So it's amazing. So I
Exactly.
like your hobby, Johnny. Yes. Yes. All right. So I think we're ready to get Johnny on stage and learn about the topic, right? Håkan?
Yes. Yeah, sure.
Okay.
Would you want to say something before
Yeah,
we start the
yes.
session, Johnny?
Yeah, that's
No, I
right.
think we're all eager to learn about Microsoft Orleans. So let's get to it.
Yes, that's good. Right, great.
All right.
Okay.
So again, thank you for having me, and thank you to everyone listening. Because I wanted to talk a little bit about my experiences with building cloud native scalable applications using Microsoft Orleans. Before I look into the technicalities, just wanted to tell you that whenever there's a question, you can ask the questions when I'm just talking. So just ask the questions. Somebody will interrupt me, and I can immediately answer your questions on the spot instead of waiting until the end. Because if we wait until the end, I probably won't let enough time to answer questions. So that's why just throw them at my head whenever you have them. So very quickly, I'm not going to talk about myself again because Håkan already did that. But I just wanted to mention that everything that I'm showing you today is already available on my GitHub. So I have a public GitHub page. It has multiple repositories. One of those repositories has been created specifically for today. So there's a link in the bottom of each of my presentation slides. And if you follow this QR code, you will also get to that specific repository. That repository contains the code that I will discuss today, but it also contains a copy of my PowerPoint slide. So you have all of the information there if you want to have a copy and look at it at your own pace. Then again, if after the session you still have some questions for me, you're always free to contact me either on Twitter or using my professional email address, and I will do my best to answer all of your questions if you still have any. So without further ado, let's dive into what I wanted to talk about, which is Orleans. Now, whenever I do talks like this, I always try to do like a theory thing on top of something that I've already built to make it more practical, basically. I don't really like these very high level and small examples. I'd like to demo things that are quite big and quite useful. So I'm going to start with this little story here. Some people maybe already may already have seen this, but many years ago, I have built this very small proof of concept game to teach my students how to use C# and .NET. I was doing teaching for many years already, and I basically got tired of teaching C# using console applications, because a console application is boring. If you have a student and that student needs to learn about how to declare a variable, how to write an if statement, how to do a loop, stuff like that, and they are just doing this in like white text on a black background, that's not really fun. And I like visiting theme parks, so I like fun. I want things to be a little bit more cool, which gives you a nice feedback. So I decided to create this game. So the point of this game is to build a robot using code, and that robot needs to fight other robots within an arena. Now, writing code to make a robot do something can be quite hard, but it also can be quite simple. So I basically decided to create kind of a scripting language. That's not entirely true. I just used C# as a scripting language. And then, of course, the Microsoft compiler platform in order to compile this code into runnable pieces of code that could actually make my robots do something. So instead of doing console applications, my students were able to, or are still able to, learn the basics of C# and immediately get feedback from whatever is happening inside of this arena. Now, the code that you see here is very easy to comprehend. Basically, this piece of code, which is just a piece of script, will be run every 2 seconds. So every 2 seconds, each robot in the arena can make a move, and that move is defined by this piece of code. So in this specific case, we basically keep a number of steps, and when that number of steps is dividable by 3, we turn left 90 degrees. And in all the other cases, we walk forward 1 tile, which basically creates a robot that walks around in squares, like 2 forward, 1 left, 2 forward, 1 left, 2 forward, 1 left, and this goes on indefinitely. Now, this is a very stupid robot because it doesn't do anything. It just walks around cluelessly, but it's a good example. So we have a couple of these methods that we can use, and we have all the power of C# to actually put into that. Now, why am I talking about this? Again, I want to teach you about Orleans based on an actual example. And this example, C# Wars, as I've called my game, had a little bit of an architectural design flaw. The architectural design flaw is that it was not scalable. When I do this with 10, 20 students, it works fine. It basically compiles and runs all of those pieces of C# script every 2 seconds. But if you play this game with hundreds or even thousands of people at the same time, maybe your computer or your program, my program in this case, is not able to run all of those scripts within that 2-second time frame, because it just takes too long. Compiling so many C# scripts in memory within that 2-second time frame is very difficult to do. And that is basically my mistake that I made while designing this game, because this is a little high-level architectural diagram of what the game looks like. We have the front end, which is in Unity. We have an HTTP API, an ASP.NET Web API, that is basically used for the front end to every 2 seconds pull for the current game state. So the API is just the access to the data that is stored in a SQL database, and the front end in Unity will just look at the API every 2 seconds, call the endpoint, get the data, and then visualize all of that data. That's it. Then on the right-hand side, we have a web UI. And the web UI is used by the students to actually deploy a new robot. So they can copy-paste a piece of C# code within that web UI. They can give the robot a name and maybe some other metadata, and then they can deploy it to the arena, and then they can see what the robot is actually doing. And then the most important part on the left-hand side, there is the worker service processor. So this piece of background running technology runs all of the C# scripts for all of the players within that arena. And that is actually the bottleneck of this whole system. Because as I told you, when you have hundreds or thousands of players, compiling and running all of those scripts within that same worker service becomes a problem. But because it's going to take longer than 2 seconds, the game is going to slow down, and eventually it will halt to a grind, basically. Grind to a halt is the correct term. So yeah, this was a problem for me. The first thing that I did to solve this was to create a separate validator service within my web UI, because I could also see that a lot of students were making a lot of mistakes. Of course, they are students, they are still learning, so they make mistakes. So the validator is there as a separate service to make sure that there's no compiler errors, but to also make sure that there's no infinite loops or runtime errors. And this was the first problem, of course, because it was part of the web UI. When somebody made a big mistake and my web UI would crash, nobody could use it anymore. By splitting it off into a separate service, a validator service, I was able to keep my web UI stable. And then when something happens to the validator, I could just restart the validator. The validator, by the way, is easily scaled. It uses gRPC as a communication protocol. So you can have like 10 validators sitting next to each other, and you can have some kind of load balancer sitting in the top to basically send all of your requests to these load balanced validators. So very easy to do. But of course, the processor is still an issue, because the processor cannot be easily scaled, or at least the way I wrote it, it cannot be easily scaled. Why? Because when I launch multiple instances of my processor, they would basically all do the same thing. They will get all of the C# scripts and compile all of them instead of spreading the work amongst them. So I was not using any queuing systems or subscription systems. So that's the mistake that I made. And of course, you could easily implement some kind of scalable approach to make sure that each processor will only do part of the complete work, so that they spread the work around all of them, and then you can more easily scale it. But it's easy. Maybe it's easy to do, but you need a lot of technology in order to make that work. You need to know what the technology is, you need to know how it works, and you need to implement it and test it. So that's a little bit more work, and maybe not so easy anymore. So throughout all of the years I've been using C# WARs, I didn't really take the time to re-implement it using a scalable way, until a couple of years ago when Microsoft introduced Orleans. Now, with Orleans, Microsoft promised that it would be easy to create full cloud-native scalable applications. And now that my starting story is finished, I can dive into what is Orleans. So Orleans is a framework built by Microsoft more than 10 years ago, and they were actually using it internally, and it's based on the actor model. And they implemented a new version of that called the virtual actor model. And the idea of the actor model, which is a design philosophy, a design methodology in software development, it is that you basically split your business logic into different actors. And all of these actors work together to make your system work as a whole. Now, each actor should have its own responsibility, which is basically the S from the solid principles, like the single responsibility. So you split up your application in all of its single responsibilities. All of these single responsibilities are your actors, and these actors work together. Now, the reason Microsoft is calling this a virtual actor model is because when you create an actor in Orleans, the actor is always there. It always exists virtually. So you always have access to your actors. And within this graphical representation, you can see that an actor, for example, actor A, can talk to another actor, for example, actor B. And communication between actors is very down to earth. It's like just calling a method in C# or in .NET. So something that we all already know how that works. We don't need to think about over a network or over the wire communication. We don't need to talk about or think about protocols. Are we going to do binary communication? Are we going to do HTTP communication? It doesn't matter. If two actors want to talk to each other, it just calls a method on the other actor. Very simple, very object-oriented, we all know how that works. Now, of course, your actors can now talk to each other, but you can also talk to an actor from the outside world, from a client. So if you have an API or a web application, of course, that API or web application can also talk to one of your actors, and then that actor can talk to other actors. And this way, the whole of your system will be able to work together and to basically get to your goal, to solve your problem that you're trying to solve with your software. application. Now, within each actor, we have kind of a life cycle. And this is what the virtual actor model does. I told you that the actor always exists. That's of course not true, because when your actor is not used or you have not yet activated your actor for the first time, it is inactive, which means it's not there, which means it's not in memory, it doesn't contain any data, it's just not there. So within Orleans, when you first call into an actor, that actor will be activated by the framework. So the framework will basically create an instance of your actor, and it will maybe fetch some data from a persistence layer, but I'll talk about that a little bit later. And then when your actor is activated, you can do communication with it. You can do method calls, it's active in memory, you can store state if you want. And then after a while, when you're done using that actor, it can actually be garbage collected by a garbage collector, and then it will be deactivated. And if it had some state or some data, that data will be persisted to whatever persistent layer you want to use. So that's it, very easy. We have actors, which are parts of your system, which have a single responsibility. They can talk to one another, they can hold some state, and this is the virtual actor model. Now, in Orleans, which is based on the actor model, we call actors grains, like tiny pieces of grain. So each grain is an actor in the actor model, and each grain is identified by these three things. I told you the whole of the application exists out of multiple actors or grains in Orleans. So each of these grains need to be identifiable. You need to know, if you want to talk to a grain, how to identify that specific grain. So a grain has, of course, an identity. But that identity can be whatever. It can be a number, it can be a unique identifier like a GUID, it can be a string, whatever you want. In my case, for example, for C# wars, there is something called a player grain, which is basically an actor that represents one player in the game. And the identity for that player can be the player name or the username for that specific player. So the next thing that's always there is a behavior. Of course, when your grain or actor has a responsibility, a single responsibility, it needs to do something. And what it needs to do is its behavior. And this is identified by a contract or an interface in C#. And that contract or interface describes all of the methods, so all of the behaviors for that specific grain, and then they are effectively implemented within a C# class. And then the third thing that is there, which is optional, can be state. So your individual actors or individual grains, they can have some state, and that state is data, and that data can be persisted or in memory depending on how you need it. If a grain gets deactivated, you can, as a developer, specify, okay, you don't need to persist this because it's just temporary data. But if it's an important data, like for example, a player with a score, when that player logs out of the system, maybe you want to retain the score so that you can re-fetch it later. That state is part of your grain and will then be persisted. Okay, so this is quite simple. Your application exists out of actors or grains, and the grains work together by just calling methods. But then maybe, why is this system scalable? Why can we create big scalable cloud systems using this approach? Well, we have grains, but we also have silos. And silos are these big things that you can see when you walk through your village maybe, and you see a farm and they have these big silos. Within those silos, things are stored. In Orleans, we will store grains inside of silos, one silo or multiple silos. And the idea for a silo is that a silo is a running application. So when I'm talking about my C# wars, and you see the processor on the left-hand side, the processor is a worker service. It's a service, it's an application that runs on-premise or in the cloud, it doesn't really matter, but it's only one single application. So this one single application can be an Orleans silo. Now, if I run this processor application multiple times, so when I scale it horizontally and I have multiple instances for the processor, when you do this in Orleans, you basically create multiple silos. And your grains live in silos. They are stored within the silos. And in Orleans, they are not only stored in silos, they of course run inside of your silo. So the silo is basically the runtime for your grains or actors. As you can see here, I have an example of 4 running silos. And these 4 silos contain grains, different kinds of grains. Because I'm creating a game, in my game I need to identify all of the different things or actors that have their single responsibility. So I can have players, I can have the full arena, I can have one single robot, I can have a script that's part of the robot, and so on. So these are all the grains that I've identified and where I built my system on top of. Now, these grains are spread around these silos, and this is where things become very interesting in Orleans. Now, you as a developer do not specify where your grains are running. The Orleans cluster will basically have an index of all of your running silos, all of your running instances, and it will decide for you where to put the grains. And these grains, they will be spread around all of the available silos in order to scale your application. So if you have 4 silos and you have 4 grains, chances are big that these 4 grains will be spread among these 4 silos, so that the load on each individual silo is identical or almost identical. So that is where the power comes from. Now, of course, you probably know that if 2 pieces of business logic, in this case actors or grains, they need to communicate to each other and they don't live in the same process. They maybe don't even live in the same server. We need to do some kind of network communication. Well, Orleans does that for you. You don't have to worry about that. The only thing you need to do is just call the method in C#, and by using code generation, Orleans will actually at runtime have code available for you to call from one grain to another grain if it even needs to go over the wire. So all of that is handled for you, which is very cool. Me as a developer, I don't have to worry about the technology. I only have to worry about the business logic, which is basically the thing that I want to work. That's the important part. Now, of course, there's some optimization there. For example, in the first silo on the left-hand side, you can see the player grain, the arena grain, the robot grain, the script grain, and so on. Now, if these grains want to talk to each other and they live within the same silo, it's going to be optimized so they will have an in-process call. So they will just have a method call to each other because they live in the same process, they live in the same memory space, they can just immediately talk to each other. It's only when the top player grain wants to talk to, for example, the arena grain in the second silo that a network call is necessary. And only then Orleans will actually perform the network call. And there's some things you can actually do to force grains to be activated in specific silos. I told you before, Orleans makes that decision for you. You as a developer don't really have to think about that, but you can think about that. There are some things you can use, some attributes you can use in Orleans to tell a grain that it always needs to be activated on, for example, the same silo as another grain. Orleans will try its best to behave to your wishes, but if it's not possible, of course, it will do something different. So you basically ask Orleans nicely, please activate this grain on the same silo, and then Orleans will try to do that for you. And maybe you've already seen in this diagram, I have my robot grain and my script grain, they're always next to each other. So there's always a bot grain and a script grain, then again a bot grain and a script grain. And for all of the silos, you can see the same thing coming back. The reason for this is because my script grain and my robot grain, they have a lot of communication. They have a lot of intercommunication because my robot and my script are actually the same thing, because my robot is nothing without its script, because its script defines what the robot needs to do. So there's a lot of communication there. And when there is a lot of communication, you want that communication to be performant. So it's going to be the most performant when both of those grains live within the same silo, within the same process, within the same memory space. So I will show you a little bit later in code that indeed you can add an attribute to one of those grain definitions to tell Orleans, please activate it within the same silo. And then there's something else. You can also see that the fourth last silo on the right-hand side only has validation grains and no other grains, and then the vice versa. So there's also no validation grains within the first 3 silos. Well, the idea for this is even cooler. You as a developer can also specify which grains can be activated in which silos. For example, to split your application into multiple parts that don't where you don't want some intermingling, for example. The reason I put the validation grains in separate silos is that in the validation grains, things can go wrong. When students make mistakes, or when people make mistakes with writing C# code, or they are trying to use reflection to hack into my C# war system, by putting all of those grains in separate silos, they basically cannot reach the rest of my cluster. So from the validation grain, you can never try to hack a robot grain using reflection or whatever, because they don't live in the same process. So you can also do that. And again, I will show you a little bit later in code. But before we look into some code, let's try a little demo. So I've created a website called web.csharpwars.com. And if you follow this link, you are able to create a player account, username, password, and then you can click a button that says create a robot from a template. So you don't have to write the C# code. You can just select the template from a dropdown. And if some of you who are right now watching do this, we can actually look at some of these robots, and I can also show you at runtime what the Orleans framework is actually doing. So web.csharpwars.com. I'm going to give it 10 seconds or 20 seconds while I drink some water, and then I'm going to do the same thing, and we'll see what happens. All right, so I'm going to follow the link myself. Let's see. Okay. So I'm logging in. Then in the top, there is play a script from a template. You can give your robot a name. It has some health and some stamina, but it's not important for this demo. And you can select one of the templates. For example, hunt down other robots is quite an extensive script that actually looks for an enemy robot and then tries to walk towards it. And then when it reaches it, it actually tries to attack it. Like in my face means when another robot is actually standing just before you in your face, then you can, of course, do a melee attack. So let's deploy this robot. And when that's successful, you can go to the home page and view the battle arena. So this runs a Unity client within your browser, and you can now see that we have some robots actually fighting. It also seems that there's a lot of lazy robots because they're just using fireballs, ranged attacks to attack one another. So we can see 4 of these robots, and I've already told you in Orleans, I basically specified a number of actors, like there's robots, there's scripts, there's players, there's arenas. So all of this should now be running in the background on Azure. And Orleans has a very cool tool for you, which is the Orleans dashboard, which actually shows you what is happening within your Orleans cluster. So here in the overview, here in the overview window, you can see we have 34 activations. And activations are actually grains, actors. So activated grains. There's 32 of them now, and they live in 8 separate silos. So the silo being the process that actually runs all of these grains. Now on the left-hand side, you can go in more detail, like, okay, what grains are actually running? There's a couple of system grains that always run within your cluster. Those are the grains that I did not create. But for example, you can see that there's 5 player grains, which means that 5 people are actually playing this game at this moment. And these 5 players, they can deploy 1 or more robots. So we also have a robot grain and we have a script grain. By the way, there's only 3 remaining, and there was 5 just before. Now there's 2, because of course they're killing each other. So when a robot kills another robot, when the robot is actually killed, the grain doesn't need to stay active, so it can be recycled. So you basically make some space for new resources to be available for your other grains. So here you can also have a live view on what is happening within the game. Only 2 robots are now alive. Now, these are your grains. You can also look at your silos. So if I click silos on the left-hand side, you can see that I'm running 8 different silos. I will show you this in Azure, like Azure Container Apps, how I deployed it. But for now, I created 2 different kinds of Orleans host applications. I have the C# Wars Orleans host, and I have the C# Wars Orleans validation host. And this is immediately the split between the silos that contain the validation grains and then the silos that contain all the other grains. That's basically the fact that the Orleans host will host all of the grains, and the validation host will only host the validation grains. So I just created 2 separate applications, and then I scaled those 2 separate applications. So the regular host application is scaled to 5 instances, 1, 2, 3, 4, 5. And then the validation host is scaled for 3 instances. So there's 3 validation silos, and there's 5 regular silos. And then for each silo, which is basically a computer with its own IP address, it actually has a list of all of its active grains that run within that silo. So we can see if we open, for example, the first host silo, we can see the memory usage, the CPU usage, and then in the bottom, we can see what grains are activated. So there's 2 players that actually live within this process, and the other players, they live somewhere else. And by default, your grains should be about equally spread around all of your silos. Of course, this is not a very good example because there's not a lot of grains, but if you have thousands of grains within your running application spread amongst all of your silos, you will see that they are somewhat equal in what they use for processing power. In this case, there's not too many, so it's not always perfectly spread around. So this is a very nice visualization of what is happening within your cluster. You can see all of your grains, you can see the silos, and you can see that it just works. Now, with this knowledge, let's look into some code. So I'm going to open Visual Studio. And this Visual Studio solution has my C# Wars solution in its entirety. So it contains all of the projects, and there's many projects here. So please bear with me. Basically, I have in total 4 applications. I have my 2 Orleans host applications, so which are web applications actually. So I have my Orleans host, and I have my Orleans validation host. So I will go in more detail in just a few minutes, but these are my silos. So that's what I was talking about when showing you the dashboard. I have 5 of these host applications running on Azure, and I have 3 of these validation host applications running on Azure. Next to that, I also have a web API, which is used by the Unity frontend to call into to get the current game state every 2 seconds. So it has a couple of endpoints. And I also have an ASP.NET MVC web application to basically host the UI that you've just used to deploy some robots to the arena. Now, only the Orleans host applications are part of the Orleans cluster. The web API and the web application, they live outside of the Orleans cluster, and they act as a client to my Orleans cluster. So when I told you before about one actor or grain can talk to another actor or grain by doing a method call, that is within your cluster. So within my Orleans host and validation hosts, the actors or the grains, they can talk to each other. But from outside, from the web application and the web API, we need to do a client call into the first grain. And that is what we call a client call, which is also supported by Orleans. And you don't really have to do a lot to make that work, but I'll just show you. Before I show you, let's show you how to create an Orleans host application. It's basically just an ASP.NET hosted application. So it's a web application. And when you look at the program.cs file, you have all of your standard things. You have your host builder to create your web application. And then you configure some app configuration. I'm using environment variables because I'm doing Docker containers. You configure your dependency injection service collection. And then you use the extension method use Orleans. Now, within the use Orleans extension method, you have your silo builder, because you are now within a single web application and you need to build your silo. So what is going to be the configuration for your silo? And I'm using a couple of things here. First of all, I'm using Azure Storage to store my state. So the state for each of my grains is stored as Azure Blob Storage. So I need the connection string towards my Azure storage account. You can also do application insights, and I can also run this on a Kubernetes cluster. But for now, I'm not running it on a Kubernetes cluster. I'm running it inside of Azure Container Apps. Now, of course, when I'm debugging my Orleans application on my local machine, I'm going to use something that is called local host clustering, which actually means that when I run this application on my local host, I need to create a cluster, an Orleans cluster, on my local host machine. So I need to specify where all of my silos are actually, where my silos are. Because in the cloud, your silos, they will be running in separate containers. But on your local machine, they're running on the same machine. So you need to specify their ports so that they don't override each other. So you can't use multiple silos on your local host that use the same ports. So you need to specify the ports manually to make sure that all of these silos can live next to each other and actually work together as an Orleans cluster. So that is the configuration you need to do right here. Else, so when I'm running in a production environment, I have a little flag like, should I use Kubernetes when I deploy on Kubernetes? If that is set to true, so when the environment variable used Kubernetes actually is true, there's a little extension method for some integration with the Kubernetes runtime. And then Orleans will use the Kubernetes runtime in order to manage all of its silos that run within your Kubernetes cluster. When you run this on Azure Container Apps, you don't need that. So you basically don't have to do anything. It will just work out of the box. So that's why there's no else here. You don't need to do these things for Azure Container Apps. It will just work. And the reason it will just work is because for your Orleans cluster, you need to specify a cluster ID. When all of your silos share the same cluster ID, they will be able to find each other within your virtual network, and they will start working together automatically. Then I have my Azure storage clustering. So basically, when you create a cluster that exists out of multiple silos, the information about the cluster is kept in memory, but you can also store it somewhere, so that when your cluster dies and reboots, that they are still able to know what the history of your cluster was, because all of that information is stored somewhere. I'm using Azure Table Storage to store information about my cluster. So I'm just doing use Azure Storage Clustering, the extension method, and I'm going to configure table service using the same connection string that I've been using for my blob storage. And then here is where my blob storage is being configured. So basically, for each grain type, for each type of grain, for each type of actor, I am creating a store. And a store is just like a logical thing where you store your blobs. So I'm creating a store for all of my separate grains. You can also just put them in the same store. It's up to you. And then, of course, I need to specify the same connection string so that Orleans knows how to connect to my blob storage. That's it. And then we have some logging. You can add application insights. And here I'm adding the dashboard. So the dashboard that I've shown you, where you can look at your Orleans information, like where's my grains, where's my silos, stuff like that. The dashboard is actually not part of Orleans. It's an open source community project that can be used within your Orleans cluster. It's written specifically for Orleans to help you to debug, to look at it from a developer's perspective. It's not meant to be used in production, so please don't use it in production. Just use it like with an if debug statement around it. so that you can learn from it, so that you can design your application together with it. And then when you deploy to production, just remove it or exclude it so that it's not part of your production cluster. The reason for this is because it's not tested for production use. And of course, it also has an impact on your cluster, because the dashboard also creates its own grains to basically work its thing. And it will also look into your grains constantly to see all of the stats, and that will drain some of the resources from your Orleans application. So only to be used for you as a developer. And then finally, there is some configuration relating to the garbage collector. I told you that when a grain is not being used for a long time, it will be deactivated. So it will not use any more resources. And you can specify the collection age and collection quantum. Collection age means that if a grain is not used for 10 minutes in this case, then it will be garbage collected. And the collection quantum means that the garbage collector needs to visit all of the grains every 5 minutes. So every 5 minutes, it will look at all of your grains. And when there's grains older than 10 minutes, not active for 10 minutes, they will be garbage collected. And you can specify different things right here. I've put it very low. By default, it's hours. I put it very low because I like my game to be recycled when it's not being used for a very short time, which I think is a cool effect. All right. This is how to configure Orleans. Now, how do you create grains and how do you use those grains? Very easy. You basically have, in my case, a separate project. You don't have to do that. I put my grains into a separate project, and I also put my contracts into a separate project. So contracts are interfaces that describe what your grains can do. And then grains itself, those are the classes that implement all of those functionalities. So if I look at contracts and grains, you can see for each of my grain, arena, robot, message, move, player, processing, script, and so on, I have a grain class. If I open this, it doesn't contain a class, it just contains the interface. So the interface for iArena grain has some behaviors. The behaviors are, for example, get all active robots, get all live robots, get the details for the arena itself, create a robot within this arena, and so on. You also need to specify your identity. So the identity for my arena is a grain with a string key. So the arena will also have a name. So I'm not using GUIDs or I'm not using numbers for the arena specifically, I'm using a string. Now, if I go, for example, to a robot grain, it has different behavior. It has get state, create robot, delete robot, update state, and stuff like that. And it uses a GUID key and not a string key. Because for me, a robot is just one of many robots, and each robot has a unique identifier. So just to show you what the different keys can be. Now, if we look at the implementation for those classes, we go to the separate grains project, and then we have indeed the arena grain. So arena grain implements from that contract or that interface that I've just shown you, and it derives from the grain base class in Orleans. By the way, this is not the grain base class in Orleans. This is a grain base class that I wrote. So if I look into the grain base class, you can see that it derives from the Orleans grain class. So you should derive from grain, and you can put whatever classes in between if you think that is necessary. I use it for my lifecycle logging so that I can log when the grain is activated and deactivated. And I don't want to do that for each grain separately. I have a base class that does it for all of my grains. That's the reason this grain base class is actually here. Now, one of the cool things about Orleans is that when a grain has a state, you don't need to worry about how to persist that state to your persistent storage. Orleans will do that for you thanks to a plugin-like system. So Orleans has a couple of NuGet packages that support multiple storage environments. And you just, in your code, you just use a persistent state, iPersistent state. So arena state is a class that lives a little bit on the top here. And it's just a C# object with some properties. So it has the exists, the name, the width, the height, and a list of bot IDs. So this is the state for my arena. And in the constructor, I'm asking Orleans, or I'm asking the dependency injection framework for an iPersistent state of arena state. So I don't care where that state is persisted or what technology I'm using. I'm just telling the framework I need some kind of persistent state. And it's then that within your program.cs, and this is what I showed you earlier, these methods add Azure Blob Grain Storage. This will do all of the heavy lifting. This will do all of the creating a client for Azure Blob Storage and then actually persisting, writing the JSON blobs to the storage account. So again, your business logic does not need to know about the technology. It just needs to know about the business logic. And if you want to switch your storage to Azure SQL, for example, you just change the configuration and you do not touch the grain itself, because the grain just uses the iPersistent state, which I think is very powerful. So this is just dependency injection. I have some grain factories that I've written myself. So a grain factory is a piece of code that will basically call another grain. So when you do grain-to-grain communication, you need to ask Orleans for another grain using its identity, and then you can call methods on top of that grain. So for example, when I look at get all active robots, it uses a helper method that here uses the bot grain factory. So we are inside of the arena grain right now, and I'm doing a call into the bot grain. And the way I do that is by calling the bot grain factory, asking it for the grain with the identifier bot ID. This is the GUID for that specific bot grain. So now I have a reference to that grain, and then I'm executing the getState method on top of that grain. And the getState is just a C# method. So this looks a little bit complicated because, I'm sorry, I made it complicated. In Orleans, it's just two separate lines. If you just use plain Orleans, you just ask a grain factory for a grain, which you specify with a type, and then the ID, and you get a reference to that grain, and then you can call the C# method on top of that. I decided to create a little helper method that does the two things in one line of code, but it looks more complicated. Sorry for that. But it's very easy. And then also, when you want to call from a client application into a grain, it looks very, very similar. So if I go to my web API, it has, of course, it's a minimal web API, so it has some endpoints. And these endpoints call into manager classes, which are kind of a mediator thing. And these manager classes, they will call into the grains. So instead of a grain factory, we are now using a grain client. But you can get both from dependency injection. So, or you ask for an iGrain factory, or you ask for an iGrain client. And the rest is the same thing. You ask for a grain, an arena grain with that identifier, which is a string in this case, and then you call a method on top of that grain. Very, very easy to do. Of course, you also need to specify that your web API is a client for Orleans. So instead of doing use Orleans, you're doing use Orleans client. And you specify what the cluster ID is. And with the cluster ID again, your client will be able to call into the Orleans cluster because it knows the cluster ID and the surrounding environment, or its local host, or its Kubernetes, or its Azure Container Apps will figure this out for you so that all of these silos will be able to find each other. So that's it. Again, I can go in much more detail, but we don't really have more time, more than 1 hour of time. So pure code-wise, I'm going to leave it at this. If you want to look deeper into this code, it is available for you. You can play around with it. You can play around with the c#wars.com website. It will always, it will be there for the coming months for you to play around with. And I'm just going to show you how I deployed this to Azure very quickly to end off my presentation. So if I go back to my browser and open this in Azure, I have actually created an Azure Container App resource for each individual process within my application. So C#Wars has 4 processes. I talked to you about this. We have the Orleans host, we have the Orleans validation host, we have the web UI, and we have the web API. Those are the 4 applications which I deployed separately. Now, these 4 container apps, they all live in the same container app environment. So they all live in the same virtual network. So they can talk to each other. It's like these are all of your individual applications within your Kubernetes cluster, for example, in your Kubernetes namespace, and they are backed by services, and you can talk. One can talk to another one using these services. But now this is Azure Container Apps. That's the only thing you need to do. When you put them 4 container apps within the same container app environment, they will be able to talk to each other because they have the same Orleans cluster ID, and they will build that clustering information for you. And I can show you that in the Azure Storage Explorer. So this is an application, the Azure Storage Explorer, which you can use to look at your storage account. And if I look into my C#WAR7 because that's the current version of Orleans, there is table storage for my Orleans silo instances. So this just contains a list of all of my silos, and it's a lot. And the reason it's a lot is because when one dies, when one is dead and gets restarted, the dead one also stays there purely for your information. So the Orleans cluster knows that it's dead, so it can't connect to it anymore, but there's also the active ones. So this contains a copy of all of the silos that live inside of your cluster, which again is also easy for you as a developer to do some debugging. And then inside of the blob containers, we have the grain state. So for each grain, I've created a store. These are the stores. And for example, when you look into the bot store, you can see that there's one JSON file left. So there's only one remaining robot who is still alive, which is basically the winner of today, let's say. And you can download that state, which is just a JSON blob containing that state class that I've showed you for the arena. And this one contains, of course, the robot. So again, you can download this, look into it, debug, and know what's going on within your cluster. Now, back to Azure. When you look at your Azure Container Apps individually, you can do some individual scaling. So if I go to Scale and Replicas, you can see that indeed my Orleans host is scaled to 5 instances, minimum 5, maximum 5. This is hard-coded by me for this demo. But you could actually, when you edit and change the scaling, you can actually do like a maximum of whatever and a minimum of whatever. So you can go for minimum 47, maximum 108, and you can add some scaling rules and even custom scaling rules depending on how many grains are in your cluster. If there's more than 1 million grains, I need to scale up to a higher number of replicas, for example. You can even go down to 0. Like when no grains are activated, when everything is garbage collected, you can scale down to 0 replicas, which means you don't have to pay any money for your applications because now there's no more running applications. And then when somebody tries to call into your virtual grain, because it's not there, but it's virtually there, Orleans will start Azure will start a new replica, Orleans will start a new silo, and that grain will be activated within that silo. So very easy to scale your applications from very small to very large, whatever you need. All right, let's see if I got everything. Let's go back to my slides. Yes, there's one more very important thing that I forgot to mention. One of the cool things of Orleans is, of course, the automatic scalability and the fact that you don't need to wrap your head around network communication between grains. Another thing is that when creating very large scalable applications and working with state, is that multi-threading becomes an issue. When you have a state in a grain and multiple other grains are trying to call into your grain to get data or to change data, you have some issues with state. Because of course you need to work with, okay, who can change my state, who can read my state, should I lock my state, and so on. Now, Orleans will figure this out for you by basically making all of your grains single-threaded by default. Single-threaded does not mean that you can't use async await. You need to use async await. Single-threaded means that within the Orleans framework, a grain can only be accessed by one caller at the same time. And that will be done for you, which means if 2 grains are calling into another grain simultaneously, that one will always need to wait on the other. So Orleans will do that queuing mechanism automatically for you. The upside to this is that you don't have to worry about locking your state, because your state will never be read or written at the same time. Orleans will handle this for you. And this helps you as a developer, because now you don't need to think about state. The only thing you need to think about is creating bottlenecks. Because of course, when you're creating queues, if many grains are trying to access the same grain, you're maybe creating a long queue, so you need to worry about that. But you don't need to worry about locking state. And that is, by the way, also the reason why you can see that my robot and my scripts are separate. And this is the final thing I'm going to tell you. My robot grain is single responsibility is the state of the robot. What is the health? What is the name? What is the location? Stuff like that. The script grain has its single responsibility being compiling and running the C# script, nothing else. Compiling and running the C# script takes a lot of time, which means that if the script and the robot are one single grain, if my arena asks my system which robots are alive, and I'm asking my robot, what is your health? And my robot at that time is compiling C#, I need to wait for that, which is not something that I want. I want my scripting to be separate from my robot, so that when I ask my robot, what is your health, that I immediately have a response. And that is why the robots and the scripts are separate, because now the script grain can run scripts all that it wants. My robot is still functional and still reacts to my calls because it doesn't need to wait for the script grain. So you basically need to think about where are my responsibilities. I know that I'm single threaded. Where do I put all my business logic? But you don't need to worry as much about technology. You can focus on how to split up your business logic into all of these actors. And with that, I'm at the end of what I wanted to talk. I'm not at the end of what I wanted to talk about. I'm at the end of my time. So if there's any more questions, we can of course discuss afterwards. And with that, I'm going to shut up now, and you can find all of my information again here, and hope you enjoyed whatever I was talking about. Thank you.
Okay, so thank you so much, Johnny. Well,
Yes.
this was a very interesting session, I think.
Yes,
so.
it was. Thank you. Thank you so much for the great presentation. I was like testing the C# wars in the background behind the scenes. Great demo. I love the code presentation, as well as the how you did it in Azure with Azure Container Apps. I'm gonna rewatch this, and I hope the listeners like it as well. We do have a question from me and Håkan. Go ahead, Håkan. You first.
Yes, I was thinking. So, as I understand it, Orleans is made to simplify when you want to develop a distributed system that should also be able to scale.
Exactly. Yeah.
But what are some examples where you don't need Orleans, that maybe Orleans is too much, or maybe it doesn't really fit? What could that be? Do you have any examples of that?
Well, to be honest, I've been using Orleans for a couple of these examples, and I've started to use it for a production project only a couple of weeks ago. So in production use, I didn't yet try it for like really large production environments, but it should be fine, because Microsoft has been using it for 10 years internally. And I forgot to mention that they mostly use it for their Xbox division. So whenever they have like these big games like Halo, for example, and there's a lot of statistics that they need to store for all of their players, which is millions of players, and if they need to, not the multiplayer specifically, but all the things around the multiplayer, like getting people linked up with each other, creating servers and stuff like that, all of those things they do with Orleans. So it's very powerful if you really have thousands or millions of simultaneous users or processes, then it's very good. If you have more simple applications that will only create like 100 grains, for example, you can use it. I don't think there's any downsides to it, but it's not really necessary in that case. So it's really powerful when you really have to use that scaling. The example that I always use, because I'm in Belgium and we have a very large electronic music festival called Tomorrowland, they do a ticket sale every year, and their ticket sale is like for millions of people at the same time. Stuff like that, Orleans will help you, because think about a ticket system. A ticket system, a perfect grain is a ticket itself. It's the sale that is linked to the ticket. It's the person who did the sale. All of these things can be grains. So when people buy the tickets, you can scale very wide. You can scale very horizontally wide, like thousands of instances of your containers running at the same time. All of the tickets and all of the sales will live in all of those silos. And then when the ticket sale is over, you can scale back down, because we don't need all of these resources, because nobody's buying tickets anymore. Until, of course, when the festival starts and people use their phone to scan a QR code at the entrance, then the ticket needs to be there again. So the virtual grain, so the virtual ticket goes back to live, and all of the information is there. So then you need to scale up again for all the people entering your event. And then after the event is done, you can scale down again. So for stuff like that, I think Orleans can be very powerful and easy to develop your applications.
Mhm. I also had a short follow-up question here, because you mentioned now that Orleans has been used internally in Microsoft for 10 years or something. But how have you experienced, upgrading to new version of Orleans? How has that been?
I've started with Orleans version 3, which was I think last year, it was last year, so early last year. It was version 3, which is, I think, one of the first versions that they made public, and they shared all of the code also on GitHub, so it's open source. And then when .NET 7 was released last year, they basically used the same numbering. So from Orleans 3, the next version of Orleans was Orleans 7. So I did the upgrade from 3 to 7. The upgrade was fairly easy to do. They had a few breaking changes, because now because Orleans is public, a lot of people have questions and remarks, and they can actually make it better, because more people are using it. So there were some breaking changes, but nothing that I couldn't fix in a couple of hours' time. By the way, also something I told you about the fact that I wrote C# Wars a long time ago. The upgrade from C# Wars to use Orleans is something that I did in only a couple of days. And with a couple of days, I mean a couple of days of my free time, so not full working days. It's actually pretty funny, because I told my wife before the summer last year, I'm going to upgrade C# Wars to Orleans during this summer. So I'm very sorry, but we're not going to be able to do things together all that often. And then after a couple of nights on my home working desk here, I went back to her and I said, yeah, it's 3 days after and I'm already finished. So she was very happy and I was very happy. So to be honest, it was quite easy to implement in Orleans. So I'm very, very, very happy with that.
Yes, that's great. Thank you for your question, Håkan. Yes, speaking of, I'm glad that you could finish the upgrade project too early, so you could spend time with your wife. That's great. Yes, one question for me, like for example, I'm a developer and I really want to get started working with the same project that you showed us in our demo. Like I really love it in a way that you could develop it with .NET, with Unity for a game, and also build it with Azure. So if I'm a beginner and I'm a developer, want to get started, where should they start looking? What's your advice?
Well, of course, there's the official Orleans documentation. I'm sorry, I'm trying to find the correct browser window here. Just give me a second. This one. So if you just search for Microsoft Orleans and type it correctly, of course, there's a lot of documentation out there. I learned a lot from that documentation. I learned everything from that documentation. It was very clear to me. And there's also Microsoft Learn courses that you can take on Orleans. So that is a very good place to start. Another thing that I did, if you go to my GitHub page and you visit the link that I shared earlier, so for example, we are now October, this is the Azure User Group Sweden. Within this, I have my C# Wars, but I also created a smaller example called Orleans Snake. I'm
Oh,
not go-
okay.
I'm not going to open it right now, but it's a very simple. It's something that I built very quickly. It's basically a
Mhm.
WinForms that shows a
Oh,
snake game, like the old school snake game from the Nokia phones.
yes.
So I remade that very. It doesn't. It looks very bad, but it works. But it's multiplayer, which means if you run multiple windows at the same time and you connect to the same game by using a game code, they will all be synchronized using Signal R, and all of the game state is being stored in Orleans. So this is actually a very small solution with only 3 projects. There's the host, the backend. There's the client,
Okay.
which is the WinForms application, and then there's the contracts. These contains all the grains. And this one, you don't need any preparation. You can just open the solution, um, set your client and host project as a startup project, start it, and then run multiple of your clients at the same time, and it will just work out of the box. It's configured for local host, so it should work out of the box.
Okay.
And then you can put breakpoints and you can learn that way, make little changes.
Yes.
That's the reason I created this little thing. I forgot to
Yes.
mention it.
Yeah, thank you for that. I did actually fork your repository already. I'm the first forker. Yeah, so I'm gonna try it out and try to deploy it and just
Yeah, we also got here a question from the audience. So we got a question here from Marcus Tenghol. How does this compare to Akka, which is another implementation of
Yes.
the model?
It's a very good question, because indeed Akka or Akka.NET for .NET is a framework that does a very similar thing. So in theory, they are both frameworks built on top of the actor model. So conceptually, they are the same. Of course, Akka is also a very mature product already. So it also has a lot of history and a lot of functionality. So they will probably not be exactly the same thing. And to be completely honest, I don't have any experience with Akka. I am, however, starting to work on a talk together with some of my colleagues that know about Akka, and we're going to do kind of a Akka versus Orleans. But I can't answer the question yet, because we just started with preparing that talk, unfortunately. So yeah, how does it compare to Akka? I can't really answer. Again, they're both the same. They're trying to do the same thing, but of course in a different way. Each has their own different quirks and different opportunities. So yeah, something to figure out. But indeed, there is something called Akka. It does the same thing as Orleans, so you could also look at that to help you with your applications.
Mhm. And also a question for me: how big, if you encounter a problem here working with Orleans, or you want to have some examples, how big is sort of the community
The
working with
community is
Orleans?
starting to get bigger. So there's a couple of people from Microsoft itself that work on the Orleans team, and they are very active in their Discord community. So I have that Discord on my computer. But if you search for Microsoft Orleans Discord, you will probably find some information about that,
Mhm.
and you will be able to get into that community. And if you ask questions, I also ask questions within that community, and the Microsoft team members, they will answer your questions as fast as they can. And I've had very good experience with that. So go ahead and join that Discord server.
okay, great. Yeah, I think we don't have any more question. Thank you so much, Johnny. We do have feedback from Marcos. Thank you so much, and awesome presentation.
Thank you.
So yes, so to those that wants to join us later after the session, we do have like a after virtual session fika, so you can join us using this link bit.ly /Ashug Sweden 10/07/23 today's date, or scan the QR code if you have more questions for Johnny. And yes, before we end our session, Johnny, thank you so much. And I did see, looked up your profile. You did write a book last year. Tell us about it. We forgot to introduce that. It's
Yeah,
about
it's
quantum computing.
Yes, exactly. It's what I call a hobby that got a little bit out of hand. Um, a couple of years ago, I decided to go to a quantum talk on a conference here in Belgium. So there was a Microsoft guy who was talking about Microsoft Quantum and what Microsoft was doing in the quantum space. I visited that presentation and I had a very hard time like understanding all of the quantum concepts. I was like, whew, this is mind blowing.
Yes.
So I decided to take a little bit of my free time and to invest it into quantum to learn more about it. And from one thing came another. So my boss at work knew that I was looking into quantum. So he basically made me do a presentation at work. Then they were like, yeah, there's a school that wants to listen to a presentation on quantum. Can you do it? So I was like, okay, I can do it. And then from the school came a local user group, then an international conference. Then people started calling me to write a book. And for some reason I said yes. and
Yes.
then
Yeah.
we had COVID. So because of COVID, I had some more time to basically write the book, and that's what I did. And indeed, last year it was released.
Mhm.
So very cool.
Yes. Yes. Congratulations on that published book. Yeah. I know how
Yeah,
it is to to write
yeah.
one in class. Yeah.
It was fun and not fun at the same time.
I can relate. Yes, the journey there. But congratulations! It takes
Thank
an
you.
effort to write one, and quantum computing is also a great topic that's interesting field as well. Yeah. So I think the time is up. We're overdue. Thank you so
Yes,
much, Johnny, and
you're
feel
welcome.
free to join us later if there's anyone that wants to join us. And otherwise, we would like to thank everyone that's watching us live and even after the live stream, the recorded one. And next, in the next 2 weeks, we also have another session coming up, which is about Azure Developers CLI. So we look forward to seeing you again next time. But otherwise, have a great weekend, everyone. Bye bye.
Bye bye.
Bye.